An exercise that students find pretty tricky each year is models and applications with exponential functions. So there are many situations in which a varying quantity can be modeled by an exponential function. And we've got A is the quantity at time t. A0 is the initial amount. B is what we call a positive constant. So if B is greater than 1, we get or have exponential growth. If B is less than 1, we get decay. And these are some examples of each. Right, so what we've got is a bacterial population increases from 5,000 to 100,000 in 4 hours. Let's get the rule. So we're going to write out a general rule, which is A equals A0 multiplied by, now we can choose any base we want to do this. This seems a little crazy. We can model this with any base we like. So I'm going to choose for this first problem base 2. Okay, and I'm going to say that then I'm going to use the basic growth model. I'm going to say that this is 2 to the, and go with me on this, I'm going to say it's to the KT. Right, and what I'm about to do is grab what we call the K value. I'm going to grab this thing here. Now this is the thing that allows me to choose any base that I want. Okay, so a bacterial population increases from 5,000 to 100,000 in 4 hours. So I'm going to sub that in. We've got 100,000 equals 5,000 multiplied by 2 to the, and it's 4 hours, so t is equal to that. So I've got 2 to the 4k. Okay, now what I want to do is solve for k2 in inverted commas, get the k value. So that's going to be 5,000 over 100,000 over 5,000. So it's going to slash 3 of them off. 5 into 100 goes 20 times equals 2 to the 4k. Okay, now what we're going to do is switch this to log form. So I'm going to write this as log 2, 20 equals 4k. And my k value is log 2, 20 all over 4. All right, so now my rule can be written as follows. I'm going to rewrite my rule as A, the amount I have, is based on there being 5,000 to begin with, multiplied by 2 to the. Now I'm going to write this as my k value, so this is log 2, 20 all over 4, and t. Right, so there's my rule. Right, how much bacteria is present after 8 hours? Okay, so we go over to the calculator here, and we're going to use that. So I'm going to say that I'm going to define a function, f of x equals 5,000 multiplied by 2 to the power of. Now I recommend you go shift power, whoops, 2 to the, and I actually think you should go to keyboard here and use the template to do this. Okay, so it's 2 to the, and we're going to say that this is a fraction, so we're going to say shift divide and write this as shift 6, I think it is, log 2, 20 all over 4, and this is multiplied by x or t in the case of the question. So to do this next question here, I'm going to simply write it as A equals 5,000 multiplied by 2 to the log 2, 20 over 4 multiplied by 8. A equals, on the calc now, f of 8 is equal to that. Obviously, we want an approximation. Wow. I even count 1, 2, 3, 4, 5, 6. 2 million bacteria. Now, so we could obviously work this one out by hand. I'm not sure how that has happened. 8 on 4 is 2, 22. Yeah, I think we shouldn't worry about doing that by hand. All right, how much bacteria is present after 1 day? Right, again, let's note that T is in hours. So 1 day would represent 24 hours. So I would do A equals multiplied by 2 log 2, 20 over 4 multiplied by 24. Interesting. So this here would be lots of bacteria. In fact, it's 3.2. Now that E thing, you need to read that as 10 to the power of 11 bacteria. Okay, and that's 10 to the power of 11. Okay, so that is going to move that decimal point just a bucket load of places to the right. Okay, it's a number so big the calculator doesn't want to display the full version. All right, here's another question here. After 1,000 years, a sample of radium-226 has decayed by 37% of its original mass. Given the rule for the amount of radium-226 can be modeled by this function here, show that K equals 1 on 1,000 log E 0.63. So we want to find the K value. Okay, so one of the things to note is when something decays by 37% of its original mass, it means that there's 63% left over. All right, so here's a little trick with these problems here. What we're going to do then is say that the initial amount, I'm going to say that I've got 1 of the initial amount, 1 unit of it. It gets multiplied by e to the k. So k is what we don't know, and t is time, which is 1,000 years. K 1,000 or 1,000k equals, and what would that become after 1,000 years? It's going to become 0.63. Okay, 1 will decrease, or 1 unit will decrease by 37% of its original mass, so it will be left with 63% of itself. Okay, so now what we need to do is just change this form and just indicate that this will be the K value. So that to do that, I'm going to say that log E 0.63 equals 1,000K. K is equal to 1 on 1,000 multiplied by log E 0.63. All right, now notice that there is a negative number. Okay, so you can see that that's a negative. So we've got decay, which seems to make sense. Okay, when something decays, it looks like that. So find the half-life of radium-226, state the value correct to the nearest year. Okay, so our function is going to be A equals 1 multiplied by e to the K value is this, 1 over 1,000 times log E 0.63 T. All right, now what we're going to do is note that the amount will decrease from 1 unit of it to half a unit, and that will be its half-life. Okay, so on the calculator, we're going to go over and work that out. So to do that, I'm going to say solve 0.5 equals 1 multiplied by. Now we're going to grab shift 4 for e to the and shift divide for the fraction 1 over 1,000 multiplied by shift 5 for ln, natural logarithm, 0.63 times x, and we want to solve this thing for x. There it is there. T equals 1,500.20 dot 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 dot. Therefore, nearest year, 1,500 years. So after 1,500 years, the amount of radium-226 will be reduced by half. All right. And another K value question here. Show that K is equal to this if the growth of bacteria can be modeled by this rule here. T is the time in minutes. Important to note that. There are 4,000 bacteria present initially, which grows to this in 6 hours, noting that this is in minutes. Okay, so what we've got 800,000 equals 4,000 times 2 to the K. T is time, that's time in minutes. So we've got 6 hours. 6 hours times 60 equals 360. Okay, slash, 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 slash. 4 into 800, should know this. 200, 200 times. 2, 360k. Okay, we're going to rewrite that as log 2, 200 equals 360k. K is equal to 1 over 360 log 2, 200. What does it look like? Just divide through by it. Log 2, 200 over 360. So there is the K value there. All right, we'll stop here for today, and I'll email you the relevant questions I want you to do for homework on this particular topic.